Another way to calculate geometric distribution expectation value is just looking into the format of the summation. So this is the summation, and you multiply 1 over p on both sides, you take the q, you can then take the p out on this first step, and then 1 minus p. It can be technically written expanded to like to the 1's power and 2 to the second. On the other hand, the original equation here can be expanded as such. Multiply by p1 minus that. This is equation 1 and equation 2. If you minus equation 2 with equation 1, you got here will become p e to the n. P, both have p here. You got this term has nothing to subtract. This term subtracted by this term will become just this. And this is 3, have factor of 3 here, this have a factor of 2, and it become like that, so on and so forth. It become a geometric distribution. And we know the geometric distribution summation. It is here. That's alpha. So pretty much is 1 over 1 minus alpha, 1 minus 1 minus 1 minus p, minus change the sign after multiply by -1. Then you got p over p equal to 1, and divided p on both sides, you got expectation value here. This looks more intuitive, easy to look at term by term, but more compactly you can write in the summation format. So this is original expectation value multiplied by 1 over p on both sides. This is the second equation. Equation 1 minus equation 2. We got p here, and we have this two term, one term here, and term here. And we set the j equals to k minus 1. Just substitute and pretty much substitute k with j plus 1. And then starting from 1 to infinity. Since the first term k equals 0 is 0, so we can start calculating from 1. As you can see, those two terms match with each other. And it ended up having this neat thing. And this is actually the probability distribution of the geometric distribution. And sum of all the possibility is 1. Then multiplied by p divided by p on both sides, we got this.